Question is, solve sine 2x plus tan x is greater than or equal to 1 by 2. So to solve this inequality, so if you observe the question, here tan x is there, here sine 2x is there. But we have sine 2x in terms of tan x. So we have sine 2x in terms of tan x as 2 tan x over 1 plus tan square x. Now substitute the sine 2x in that given inequality, then the inequality becomes 2 tan x over 1 plus tan square x plus tan x is greater than or equal to 2. So if you take the LCM, here this is 2 tan x, here 1 plus tan square x is LCM, therefore 2 tan x plus tan x into 1 plus tan square x is greater than or equal to 2. So here denominator is anyways positive, that is this 1 plus tan square x is positive. If you take out 1 plus tan square x this side, that is right hand side, inequality remains same because 1 plus tan square x is a positive quantity. So this implies 2 tan x plus tan x plus tan cube x is greater than or equals to 2 times 1 plus tan square x. This implies this is 3 tan x plus tan cube x minus 2 minus 2 tan square x is greater than or equal to 0. If you rearrange the terms, then you will get cubic expression, that is tan cube x minus 2 tan square x plus 3 tan x minus 2 is greater than or equal to 0. Now we will factorize this expression, that is tan cube x minus 2 tan square x plus 3 tan x minus 2. So for that one, what you do is, so you take this equation, first you factorize this one. How to factorize this cubic? By synthetic division. First you predict one root. So tan x equal to 1 if you substitute in this equation, then it becomes 1 minus 2 plus 3 minus 2, that is 4 minus 4. Therefore it satisfies. So now tan x equal to 1 is the root of this equation. Now by synthetic division, we factorize this one, 1 minus 2, 3 minus 2. Tan x equal to 1 is one root, therefore 1, 0, 1, 1 minus 1, minus 1, 2, 2, 0. So now this tan cube x minus 2 tan square x plus 3 tan x minus 2 can be written as tan x equal to 1 is a root, therefore tan x minus 1 is a factor, therefore tan x minus 1 times here remaining is quadratic, that is in which coefficient of x tan square x is 1 and coefficient of tan x is minus 1 and constant is 2. So this is tan square x minus tan x plus 2 plus 2. So this is the factorization. So this is the factorization. So but what we need to solve? We need to solve this inequality. It's inequality. So now this inequality becomes after factorization. Now we need to solve this inequality. Therefore, the tan cube x inequality becomes, after factorization, tan x minus 1 into tan square x minus tan x plus 2 is greater than or equals. So, this is the inequality which we need to solve. To solve this one, first you see this quadratic in tan x. So, this is tan square x minus, I will write this tan x as multiply and divide by 2, then it becomes 2 times tan x into, you multiplied by 2, so it divided by 2. Now, we have written this in the form of tan a square minus 2ab. We need b square to make it a perfect square. That's why add and subtract 1 by 4. Already 2 is there. So uh, this is the second bracket. This first one as it is, tan x minus 1. This is greater than or equal to 0. This implies tan x minus 1 times, so from tan square x to 1 by 4, this part is a perfect square. So this part is a perfect square. Therefore, that can be written as tan x minus 1 by 2 whole square plus this is 2 minus 1 by 4. This is greater than or equal to 0. So this implies this is tan x minus 1 into tan x minus 1 by 2 whole square plus this is 7 by 4. This is greater than or equal to 0. So here the second factor, so this one is always a positive quantity, it is always greater than 0. Here product of two numbers is greater than or equal to 0, one is strictly greater than 0, then this first factor, that is tan x minus 1, must be greater than or equal to 0. Tan x minus 1 must be greater than or equal to 0. That implies tan x is greater than or equal to 1. So now we need to solve this inequality. This inequality we need to solve. So this is a trigonometric inequality. Always try to solve the trigonometric inequalities graphically. That is, let y1 is equals to tan x and y2 is equal to 1. So you consider this as one function, that is y1 is equal to tan x. This one has another function, y2 is equal to 1. Here whenever the trigonometric inequalities are, here two dissimilar functions are there. Tan x and 1 are two dissimilar functions. Whenever the dissimilar functions are there in inequality, you try to solve graphically. So you draw the graph of y1 is equal to tan x and y2 is equal to 1 on the same coordinate plane. So here this one is this is the graph of y1 is equal to tan x. This one is the graph of y1 is equal to tan x. Now you draw the graph of y2 is equal to 1 on the same plane. So y2 is equal to 1 is a line which passes through the point 0, 1 and parallel to x. So the line will be y2 is equal to 1 line be like this. So this is y2 is equal to 1 line. So this one is y2 is equal to 1 line. So now our requirement is what? Tan x must be greater than or equal to 1. So in this one you take this branch, that is from minus pi by 2 to pi by 2. You take one branch. In this minus pi by 2 to pi by 2, in which interval tan x is greater than or equal to 1 is possible. Geometrically, we need to find the interval in which tan x graph is above the line y equal to 1, including tan x equal to 1. So we need to find the values of x for which tan x graph must be above 1 and tan x is including tan x is equal to 1. So those values of x is our requirement initially. So for that one, first you solve where this uh, y1 is equal to tan x, y2 equal to 1 intersect. This point we need in this in between minus pi by 2 to pi by 2, where this tan x and 1 intersect. This point we need to find. That is tan x equal to 1, where tan x is equals to tan x becomes 1, when tan x is equal to 1, we need to solve for intersection. Therefore, in between minus pi by 2 to pi by 2, x value is 45 degrees. So, this point is, this intersection point means the x coordinate is, this is pi by 4 here. Therefore, this is the point of intersection, that is pi by 4 comma 1. This point is pi by 4 comma 1. So, now if you observe the graph carefully, in which interval from minus pi by 2 to pi by 2, in which interval tan x graph is above the line and tan x is equal to 1. So in the interval minus pi by 2 to pi by 2, in the interval minus pi by 2 to pi by 2, tan x is equal to 1 at pi by 4. Tan x is equals to 1 at pi by 4. At pi by 4 tan x equal to 1. Now from pi by 2 to pi by 4 to pi by 2, tan x is above. From pi by 4 to pi by 2, tan x is above. So this part is our requirement. So you observe this part. So now the solution set is in between minus pi by 2 to pi by 2. The solution set is, that is in the interval minus pi by 2 comma pi by 2, tan x is greater than or equal to 1 if x belongs to closed pi by 4, closed pi by 4 to open pi by 2. In this interval, this tan x graph is above the line y is equal to 1 and tan x equal to 1 at pi by 4. Now, this is the solution in the interval minus pi by 2 to pi by 2. Now, generalize. If you generalize the solution, the general solution will be, you add n by both sides. That is, in this minus pi by 2 to pi by 2, our solution is what? Pi by 4 is less than or equals to x is less than pi by 2. This is our solution. So, general solution will be, therefore general solution will be add n pi both sides. Therefore n pi plus pi by 4 is less than or equals to x is less than n pi plus pi by 2, where n is an integer. So this is the general solution. So our solution, so this part is when n is equal to 0. Where n is an integer, if you put n is equal to 0 in this inequality, you will get pi by 4 to pi by 2. So that is this point. Now, if you put n is equal to 1 over here in this one, if you put n is equal to 1, you will get 5 pi by 4 to 3 pi by 2. That is next interval you will get. That is, if you put n is equal to 1 in this one, if n is equal to 1 in, so this is the solution. In 1, then what you get? Pi plus pi by 4 is less than or equals to x is less than pi plus pi by 2. So that is 5 pi by 4 is less than or equals to x is less than 3 pi by 2. In this interval also, tan x is greater than or equal to 1. So that is 5 pi by 4. From the graph, this 5 pi by 4 will be this point of intersection. This one is 5 pi by 4 to 3 pi by 2 is 3 pi by 2. So this is the interval 5 pi by 4 to 3 pi by 2. Again, tan x is greater than or equal to 1. So this one. So next, if you put n is equal to 2, then you will get this part. If you put n is equal to 2, you will get this part. So general solution is what? This is the general solution.